Okay, Assalamualaikum and good morning. Okay, so I don't think my internet is really good now. So I just record it lah. Better than the direct online. Okay, so we continue with part G of the chapter 3, which is the feasibility analysis. So I hope you already watched the previous video. And I want to remind you again, make sure you finish up the assignment, 5% assignment for the presentation. It is a group assignment, maximum 4 member. Okay, so I remind again, that is 5%. Okay, so you have academic service learning is 30%, test 15%, and another 5% is presentation. Okay, don't forget about that. Okay, so make sure you submit it before week 15. Okay, so initially feasible analysis for wind is quite a bit simple. So of course the first one is the initial site feasibility and zoning. Of course, when you want to install the wind turbine, you have to have the zoning lah, the feasibility, whether it's good or not, you have enough wind or not, and of course the zoning, you cannot just build it anywhere you want, you have to look at the zoning. Okay, and you have to do the risk assessment, especially at the near the the land is not stable, you have to check it. Okay, access and topography, you have to evaluate the physical terrain and means of access for heavy machinery during construction. So to build a wind turbine, the blade itself is quite heavy. Okay, so you need to have heavy machinery just to bring the blade and of course construct the tower. So usually this one, that's why wind turbine usually build near the shore, because you can bring the equipment using boat. Okay, and also grid connectivity is better to build the wind turbine near the grid. If not, you have to build the wire for the grid connected to the wind turbine, so that will become very costly if it is far away. Okay, and of course you have to have approval from the utility. You cannot just directly connect to the grid, you have to do the stability assessment and everything, and of course you need to have a proper tarif lah. Okay, so in Malaysia, I think the latest one is called ATAP. You already learned in chapter 1. Okay, we have the tarif for but that one is more towards the PV lah. Okay, so technical and special requirement. Okay, wind turbine technical footprint required to ensure safety and efficiency. So of course the turbine spacing standard separation is typically 5 diameter. Okay, to avoid any interference. Okay, what it means by 5 diameter, if your the blade is 50 meter, so the diameter of the wind turbine is 100 meter. So you need to make sure it is almost 500 meter lah, something like that. Okay, if not, the wind is already taken by the wind turbine, the energy, and then suddenly another wind turbine want to take another energy, basically it cannot work lah. That's why you need to have some spacing. Okay, so land area, of course you need to have a very large land area and also buffer zone. Okay, you cannot have any building or dwelling within 300 to 500 meter, if not the wind will be blocked. Okay, and of course wind turbine create noise. If the building is too close, it will disturb the people in the building. And also you have a shadow, okay, flickering. So this one is quite problematic also. If someone live near the wind turbine, you have the shadow on and off. Okay, so the light will turn on and off from the sun, shadowing with the wind turbine. Okay, it gonna have problem. Okay, so basically this one you have to consider. And then you have a size, application, and economic scale of the wind turbine dictates by the intended use of the energy. So you cannot just build whatever you want. basically you have to properly scale it. Okay, economic principle, economic are maximized when the turbine size match the load while leveraging the economic scale and using the equipment with the proven track record. And the purpose lah, whether this energy is on-site use, sale, or the load needs to be determined, and final infrastructure is investment. Okay, basically when you want to build this, you have to make sure you calculate the properly lah. Is it needed or not? If not needed, why you build it? Okay, so that is the consideration. Also, you have to you remember the well book. Okay, well book distribution. This is the well book distribution. You have to consider this. Okay, you have to calculate the energy yield based on the well book distribution, hours per years. Okay, so how many hours is 1, how many hours is 2 and 3 and so on lah. In the final exam, usually we will ask something like this lah. Basically, we have the well book distribution of hours per year of the wind energy. X-axis is the wind energy, wind speed. Y-axis is the hour per year. So you have to calculate lah. Like 1, 2, 3, usually under the cut in speed, basically no energy at all is collected, and then after that you can calculate the energy collected. So the thing that you calculate in the equation, remember the equation of wind turbine. Okay, so that is the power. So you have to multiply by this to get the year. So make sure you know how to calculate this. Okay, and then cost of 5 megawatt wind. This is just example. So you can see here, usually the wind turbine 1/4 is the tower cost, this one, and then another 1/4 is the rotor. Okay, so rotor is actually remember before this I show you that you need to use a special material. Okay, you have to be light, durable, and many things lah. You have to recall back that one. I think it has 7 characteristics. Okay, make sure you memorize it. And because of the special material used, the cost of the blade become very high lah, this one. Okay, so others doesn't have any cost lah. Usually the tower is 1/4, the blade is 1/4, and gearbox is usually around 12.5% gearbox. If you don't have a gearbox, you can reduce the cost a lot lah. Generator is quite cheap. Okay, other also quite cheap lah. Okay, so this one doesn't consider the transportation. Basically transportation also cost is quite high. Okay, so basically the thing that you need to know is the tower is 1/4, blade is 1/4 of the cost. Okay, others are low. Okay, also gearbox is also around 12 to 13% lah usually. Okay, so that's it for cost of wind turbine. Okay, cost analysis. Okay, so make sure you at least remember these 3 lah, the highest cost. Okay, converter also around 5%, it's not very high lah. Okay, I think this is the last one. I think, yeah, the offshore wind turbine. So I just continue lah. Okay, so the offshore wind turbine, basically the one that we talk about is usually we talk about onshore lah, basically near the land lah, on the land or near the land. Okay, so offshore, not near the land, on the land lah. Okay, offshore is basically on the sea. Okay, so this is the offshore wind turbine. So basically it is placed on the sea. So it has several advantages, because at the sea you don't have to consider the cost of the land, same as solar, right? So solar before is built on the lake, built on the water. Because of the cost of the land, you can remove that, because the cost at the sea is much more cheaper lah. Okay, so of course another thing, the advantage is the wind is higher at the sea. Okay, there is no building, there is no obstacle, so the wind is much more faster. Okay, so that is the more obvious choice lah, why there is a offshore wind turbine. Okay, so the thing that you need to consider is sorry about this. This is quite new. Before this, the slide is quite different. Okay, so the first thing that you have to know is the technology advancement, safety and protection. So you can see here, offshore turbines are specially modified to survive harsh marine environment. So you have to build the wind turbine is much more for harsh environment lah, because you put it on the sea. Okay, you have wave, you have salt. Okay, it can cause corrosion, something like that lah. So structure reinforcement to withstand wave, wind and ice loading. So in Malaysia maybe no, but in the sea, for something that at the north or at the south, you have ice. Okay, ice moving at the sea and crash into the wind turbine. You have to consider that lah. And you have to consider the pressurized nacelle to prevent corrosion from salt spray. So this is what I tell you before. When you at the sea, okay, you have a metal structure, it will corrode easily. Okay, maybe you know, maybe you don't know. Okay, if you put your car near the sea, okay, or your house near the sea, basically your car will corrode easily because of the salt water. Okay, so to avoid that, they usually pressurize the nacelle. Pressurize means that basically you make it close compact system. Okay, nacelle is the housing of the wind turbine. Basically you pressurize it. Okay, and then you have advanced corrosion protection, high grade coating in internal climate control, automatic lubricant system and thermal control for gear oil. This one, because it is at the sea, is harder to maintain lah. That's why you have automated lubricant system. And you have lightning protection system. Okay, so when at the sea, okay, the highest point is the wind turbine, because everything is at the sea level, right? And you suddenly you have the wind turbine, so basically you need to have a proper lightning protection. And also you have a navigation and aviation warning light. Okay, so you have to put the light lah, because wind turbine is kind of high, and if the plane, the small plane lah, not very big commercial plane, that one is very high usually. But the small plane, you need to put some light lah. Okay, and also boat, you have to be careful. So if you don't put light, they can crash into the boat can crash into the wind turbine. Okay, and tower are typically light gray and off white to reduce the impact vision. So usually the this one, the offshore wind turbine, usually even though it is at the sea, but is usually near the shore, cannot be too far, because you have to consider the wire to transfer the energy into the grid. So you cannot just build far away at the sea, cannot. You have to close to the shore, even though okay, you have to build it near lah. Okay, so to avoid any visual impact, you paint it like gray or off white gray. So by painting like this, you basically from the sea, you cannot see the wind turbine. Okay, or you barely see the wind turbine. So that means that reduce the impact lah, visual impact. But in the lower section of the wind turbine, usually we paint it bright color for vessel safety lah. So if the boat near the wind turbine, they can see it properly. Okay, next, structure, load and standard. One of the greatest challenge is accurately load prediction. Analyze must be considered the dynamic couple between turbine motion and platform motion. Okay, so in the land, okay, the wind turbine in the land, you don't have to consider lah the switch, the sway, pitch, roll, yaw. Okay, I think pitch and yaw, I think you have to consider lah. Okay, basically not everything you have to consider is simple, because the land is steady. But in the sea, the land is not steady lah. That's why you have to consider the dynamic coupling. Okay, floating turbine require detailed mooring and line dynamic. Foundation and substructure account for a large share of total system cost and complexity. Of course, the cost is much more higher lah for the sea. Okay, but if not mistaken, recently almost the same as the land. Okay, before this, the offshore wind turbine is much more costly, but after certain time is almost the same as the land lah. Okay, Corrosion is a major design concern. Remote monitoring method adopted from the oil and gas company are promising. Okay, so corrosion and monitoring lah, that is the usually is the focus for the offshore wind turbine. And of course you have a design standard. Usually we don't ask the number here. Okay, no need to worry on this. Okay, and then planning for and foundation time, and this one is quite popular question in the final exam. So you need to know lah water depth and the type of foundation. So you have monopole foundation, gravity based structure, tripod pile structure. This one you need to know lah the depth. Usually this one lah, monopole is the common one, around 30 meter depth, and then the rest. Okay, and the question usually asks you to draw the monopole. Okay, gravity foundation and the tripod. I think if not yeah, tripod is the future design. Usually these two. Okay, so this one is monopole also. This is yeah, monopole, gravity foundation, monopole, and the tripod. Okay, so make sure you know how to draw it. Okay, so before this the question asks how to draw at least 3 type lah. And then you have the land based, shallow water. Okay, transitional water. Usually you have to build the tower properly lah to the land. But for the deep water, it's just not yet, if not mistaken, now still not yet. Okay, there's no wind turbine on the top of like a floating boat, something like that. Okay, it's not stable enough. Okay, so maintenance and reliability, this one you need to require a service vessel, helicopter, and jackup rigs for major repair. So you have some helicopter, service vessel. Usually you have a helicopter place to land, normal thing, for something on the sea. Okay, you have a blade inspection, may use long range photograph or drone. Okay, so you cannot just have a crane, okay, directly at the sea. So usually we use the photograph or drone. Okay, only you have a specialized condition monitoring, prognosis, health monitoring system. Okay, due to the remote location. Okay, so for the impact, environmental impact, of course the bird pollution, but usually it's very low. Of another thing you have to consider, underwater noise lah. During piling, when you do the piling in the water, you have to consider the noise lah. Is disturb the marine life or not? Okay, it will affect the behavior of marine mammal, fish, and seabird. Okay, so you have to consider that lah when you do the offshore wind turbine. And then economic and benefits. Okay, so reduce the cost by improve wind and wake modeling, lightweight turbine material, eliminate gearbox. Why? Because gearbox require maintenance and it's very hard to do maintenance at the sea. Okay, so load mitigation, control strategy, hurricane and typhoon. This one usually you have to memorize lah. Okay, so this one, okay, this is the one that I said. Basically the land base and the what you call the offshore, the costs have reduced tremendously lah. Okay, it's almost the same. Okay, and transportation of wind generated energy. Okay, remember I said you cannot build it far away from the land because you have to transport the energy, and the cost of transportation of energy, especially in the water, you cannot just use the normal cable. You have to use specialized cable underwater to transport the electricity. So usually they have ESP, electrical service platform. Basically each wind turbine is not directly connected to the land. The cable is not directed to the land. So basically they are collected together into the ESP, electrical service platform, and then one cable goes to the land. Okay, so ESP is basically substation and collection hub lah. Okay, and then high voltage subsea cable transmit the power to the onshore substation. Okay, you have to collect it and then transport into the land. Okay, buried beneath the seabed for protection. Subsea cable present major capital cost. So like I said before, the cable use is quite expensive. So that's why you have to consider it close to the sea. It's close to the land. So this is also a popular question. You have to draw it. So you can see here, this is wind turbine, wind turbine, wind turbine. 3 wind turbine. Draw it like this, and then you connect this together into the offshore substation or ESP, and then the offshore ESP goes here and then go to the on land substation. So make sure you know to draw this lah. This is popular question. I think if not mistaken 2 times already before come out. So this is ESP, the electrical service platform. Okay. So this is way to lay the cable. Okay. So this one also, okay, already explained. Okay. So this is the drawing lah, like the one that I said. This is popular question. Okay, make sure you know how to draw this. Okay. Oh, there is another one. This is new. This before this there is none for part I. Maybe I just continue. Emerging wind turbine technology. So before this, the on land is the most matured one. Offshore also quite matured. This is the emerging wind turbine technology. So beyond conventional HAWT and VAWT. Okay, conventional wind turbine are large and location dependent. New wind turbine concept aim to harvest low speed, reduce cost, noise, and land use, operate in urban, offshore, or remote area. This is several innovation, basically some small innovation lah for you to see. Okay, so this is a kite wind turbine. Okay, airborne wind turbine system. So basically what is it is you just put the wind turbine at the kite. Either put at the kite or on the land, and the turbine is pulled by the rope connected to the kite. Okay, so this is high altitude wind turbine, tethered kites or drone instead of tower. Okay, because it is very high, around 200 to 1000 meter, the wind is stronger and more consistent lah. Far away, the higher you go, the higher the wind speed. Okay, and then electricity generated. Okay, this one is the one that I said. Either the generator is on the ground and the tether, okay, the rope pulling by the kite will move the turbine, or onboard generator. This one is basically the generator is on the kite itself. So you have 2 new technology lah. Okay, so advantage is higher wind speed, okay, higher potential, higher energy potential, less material and land requirement because everything is on the kite. Suitable for offshore and remote area lah. Okay, so you cannot build this on the building. If the wind suddenly drop and the kite suddenly drop, and it can hurt people lah if you put this near the building or something. Okay, this is suitable for offshore or remote area lah. Okay, so the complex control system, this one have very complex control system because onboard generator basically you have like a plane, okay, flying the system. So basically you have to have a complex system, or the on ground basically when the wind speed push it, okay, you have the kite will go up and up lah, but after that you have to rotate back and you have to design the wind turbine the wing so that it's not wind resistant anymore lah when you rotate back. Basically you can look at the YouTube lah and how it is work. Okay, so this is the one that I told you, on ground generator and the onboard generator. Okay, so I suggest better you look at the YouTube to see more detail on this. Okay, this one is another not so popular because the power produced is not very strong lah. Okay, so this is a bladeless wind turbine. Basically you have tube vibrate, okay, producing electricity. Okay, so use wind induced vibration instead of rotating blade based on vortex shading phenomena. This one lah. So no rotation part, silent operation, bird friendly and compact. Okay, but the power is low lah, suitable for small scale or sensor application. Okay, usually for sensor lah or small scales because the power produced is quite small. Okay, so this is also a development technology. Okay, not a mainstream one. Duct or shrouded wind turbine. Instead of making a very large large turbine, okay, much more larger blade, you put a duct or shrouded. Okay, basically this one lah. Okay, enclosed duct or diffuser increase the wind speed passing through the rotor. So because of that, you get higher wind power, better performance in urban area, and reduce blade tip noise. Okay, basically the larger the wind turbine is, usually the noise is much more larger lah. Okay, so basically if you do this, reduce the blade tip noise. So limitation, increase cost and structure complexity, and also limitation, increase the cost and structure complexity, and the large scale adaptation lah. Basically this one is much more bigger and heavier lah, so that gonna be a problem lah. And then this one, like I said before, for floating, for offshore wind turbine, usually you have to pile down the tower. Okay, the floating one is under develop. Okay, still develop under research. Okay, wind turbine mounted on the floating platform. Okay, has a stronger offshore wind turbine. Like I said before, the further you go, the higher the wind speed. Enable wind access in the deep water and large power capacity. Okay, of course, higher installation and maintenance costs. Okay, because you have to remember the cable, underwater cable is quite expensive, and of course complex engineering and control because it's floating and rotating. Basically you have to balance everything up. Okay, so that's it for chapter 3. So I hope everything's okay for you. Make sure you watch the video and everything. Good luck. Make sure you come to the final exam. If not mistaken, is, I forget lah. Say 11, I think. 11 July. Make sure you check back. That is only the draft. Okay, make sure you check back the final exam. Make sure you come. It is during weekend. Okay, don't forget to wake up. Okay, make sure you come to the final exam. Maybe later I will give some tips on the final exam. Okay, so that's it. Okay, we have ended our course. Okay, so on week 14 and week 15, so there will be no more class lah. For the presentation, make sure you submit to me the video. Okay, so that's it. Presentation is 5%, and make sure you complete all the academic service learning report and everything, because if you miss one, basically you don't get all the mark. And later I will give you peer review. I will give you peer review. You will have to fill out the peer review because everyone will get mark depending on the peer review. So recall back the rubrics for the ASL. Okay, so that's it. Okay, see you again during the exam lah. Okay, thank you.